Hello! I wanted to go through these quadratic modeling questions for you, and so I thought instead of making a print copy of the solutions, I'd go ahead and walk you through it so you could listen to the justifications. So here, let's look at question 2. It says the number of bushels of barley an acre of land will yield depends on how many seeds per acre you plant. From previous planting statistics, you find that if you plant 2 million seeds per acre, you can harvest 22 bushels per acre. And if you plant 4 million seeds per acre, you can harvest 40 bushels per acre. As you plant more seeds per acre, the harvest will reach a maximum and then decrease. And this happens because the young plants crowd each other out and they compete for food and sunlight. So assume, therefore, that the number of bushels per acre you can harvest varies quadratically with the number of millions of seeds per acre you plant. So what this means is there's a function whose input is the number of millions of seeds per acre that are planted, and then the output is how many bushels per acre that are harvested. So in order to proceed, we need to figure out 3 ordered pairs where the input is millions of seeds per acre and output is bushels per acre. Now, if you read through the problem, you'll see that it's only explicitly giving you 2. So the third of them is not given above, but should be obvious. Okay, so let's figure out what those are. So if we look through, we see that if you plant 2 million seeds per acre, then you can harvest 22 bushels per acre. So that's actually giving us 1 ordered pair. Those 2 pieces go together, so 22 is 1 ordered pair. We also have that if you plant 4 million seeds per acre, you can harvest 40 bushels per acre. That's giving us another ordered pair. And that ordered pair is 4, 40. Okay. And the third, the one that's not given, we have to think about logically what's happening. If you plant seeds, then there is a harvest. Okay. Well, of course we can't plant a negative amount of seeds because that doesn't really make any sense. So our domain is not going to include any negative numbers. But what about 0? Okay, if we plant no seeds at all, what is going to be the output? Well, it should make sense that if you plant no seeds, there's nothing to harvest. So that's our third, that's our third ordered pair. So we're going to use these 3 ordered pairs, and we're going to write a particular equation for this function. And remember, this is going to be quadratic. Okay, so now what we want to do is take our 3 points and fit them to a quadratic function. So in order to do that, we're going to input our x value and say that we output the y value. So for instance, if we get 0 squared a because we're inputting 0 for x, and the a is what we're trying to find, plus 0 times b plus c, that needs to equal 0. Realize that 0 times anything is 0, so this whole thing is 0. This whole thing is 0, so all we have is c equals 0. So it's really helpful. We know what c is. So we're going to start inputting c equals 0. We can actually at this point say that our quadratic function is going to look like y equals ax squared plus bx plus 0, so I'm just not going to write it. Okay, so now we can input our other 2 points. 2 squared a plus 2b equals 22, and 4 squared a plus 4b equals 40. I'm going to go ahead and simplify 2 squared and 4 squared. So we get 4a plus 2b equals 22, and 16a plus 4b equals 40. And now we have a system of 2 linear equations and 2 unknowns. So we can solve this just like we were doing in chapter 4. I'm going to choose to eliminate b. So I'm going to multiply the top equation by -2 and leave the bottom equation alone. So I get -8a minus 4b equals -44. and 16a plus 4b equals 40. So now when I add these two together, I get 8a equals -4. Remember, that's the whole point. I'm trying to make the coefficient of one of the variables have the same coefficient with opposite signs so that when I add them together, it is eliminated. Like in this case where I made them both 4, but made one of them negative. So now I have an equation in just one variable, 8a equals -4, so divide both sides by 8, and we get a equals -1/2. Once we know that a is -1/2, we can take a equals -1/2 and put it into another equation. I'm going to choose this top equation here, and once I know what a is, I can figure out what b is. So I get 4 times -1/2 plus 2b equals 22. That means that -2 plus 2b equals 22. And so 2b equals 24, and b equals 12. So now we know all of what a, b, and c are. A is -1/2, b is 12, and c is 0. And I found those so that I could write this function that goes through these 3 points as a quadratic. So I'm trying to write this as y equals ax squared plus bx plus c. We know a is -1/2, b is 12, c is 0. So my quadratic function is y equals -1/2 x squared plus 12x. I can go ahead and check and make sure this works. I'm going to check each point. So 0, 0. If I input 0 where the x's are, I get -1/2 0 squared. Of course, -1/2 0 squared is 0. And 12 times 0 is also 0. So those two together give me 0. That's good, because if my input is 0, my output is also 0. Now, left off that 0. Now I'm going to check 222. I'm going to input 2 for the x's. And I get -1/2 2 squared plus 12 times 2. And I'm not really sure what happened to what I was doing, but let's just go forward. Okay, I'm going to check 222. I'm going to put 2 in for the x values. And if I do that, I get -2 plus 24, which is 22. So if I input 2, the output is 22. That's good. That's what I wanted. And I'm going to check the last point, 440. I'm going to put in 4 everywhere where there's an x. And I get -8 plus 48, which is 40. So that's good. So this quadratic function that I've come up with actually goes through those 3 points, and that's what we wanted. Okay, so now, what's the next question? It is, how many bushels per acre would you expect to get if you plant 16 million seeds per acre? Okay, so this is, what is my output going to be, since bushels per acre was the output, if the input was 16? Okay, so let's go back to our whiteboard. We know our function is y equals -1/2 x squared plus 12x, and we want to know what is the output when the input is 16. So we take y, that equals -1/2 times 16 squared plus 12 times 16. And so that gives us 128, -128 plus 12 times 16, which is 192. And I put these two together and I get 64. So our answer is 64 bushels of barley. Okay, now the 64 bushels of barley is greater than the output if 4 million seeds per acre are planted. Okay, and we're eventually going to try to find a maximum value. Okay, so what's our next question? Based on your model, is it possible to plant so many seeds that you harvest no barley at all? Okay, so imagine with me for a minute and just practically considering, I know this isn't realistic, but imagine you plant so many seeds that they're so thick on top of the ground that they can't, some of them can't even, what am I trying to say? That they're so thick on the ground that they're just one full layer. There's no space between them. You can imagine maybe saying that that's not going to harvest any barley at all. So even practically speaking, there is a point at which there's no barley to be harvested. The other thing to think about is this is a quadratic function. And so if we think about what the graph is going to look like, we've got -1/2 x squared plus 12x. This is going to be a parabola. We also know this parabola is going to open down because a is -1/2. It goes through 0, 0. And so it is eventually going to hit the x-axis again, which would be the point at which it would not harvest any barley at all. And so according to this model, there is a point where that happens, okay, according to this model. So the answer would be yes, and we would say, what is it? So we're trying to say, when does 0 equal -1/2 x squared plus 12x? Okay, and the way that we can solve this, well, this is a quadratic function. So quadratic functions we can solve with the quadratic formula. To use the quadratic formula here, a is -1/2, b is 12, and c is 0. So let's use it. We get x equals -12 plus or minus the square root of 12 squared minus 4 times -1/2 times 0. All over 2 times -1/2. Okay, so we get -12 plus or minus the square root of, we get 12 squared, and notice there's a multiplying by 0 under here, so this whole term is 0. So we get the square root of 12 squared, so I really get plus or minus the square root of 12. The square root of 12 squared, which is 12, all over 2 times -1/2, which is -1. Okay, so now we get -12 plus 12 divided by -1, which is 0. -12 minus 12 divided by -1. Okay, or in other words, -24 divided by -1 is +24. So the answer is when you plant 24 million seeds per acre, no barley is harvested. According to this model. Okay, and an easy way to check this answer is to go ahead and take 24 and input it into this quadratic function. And you will find if x is 24, then y is 0. Okay, so let's go then and see if we have answered the whole question. We still have part E, and we want to plot the graph of this quadratic function in a suitable domain. Okay, so let's do that, and let's get some graph paper. Here we are, And we're going to say that we have several points that we know. Our suitable domain, well, we can't plant a negative number of seeds. We also can't let the output of our bushels of barley be negative. So our domain is going to go from 0 to 24. All right. We also know that I'm going to let these go by 5s here so we can go all the way up to 24. And we know several points. We know 0, 0. We know, oh, I have that labeled incorrectly. That should say 25 there. Okay, there's 24, 0. We also know the points 2, 22. We know the point 4, 40. We know the point 16, 64. And we're going to have to plot those. And 16, 64. So we're going to need to go at least up to 64, probably a little bit greater, because the maximum is going to occur at our vertex, which is halfway between 0 and 24, or at 12. Okay, so let's go ahead and make our y-axis go up by 20s. 20, 40, 60, 80. And also, so that we can figure out where exactly that vertex is, we're going to go ahead and input 12, because 12 is halfway between 0 and 24, and see what happens when we input 12. So let's see, y equals -1/2 times 12 squared plus 12 times 12, and this is going to give me -72 plus 144, which is 72. So we also have the point 1272. Okay, that's actually pretty great because we're going up to 80. Okay, so 1272. Let's see, let's start at 2. 222, and then 440, and then 1664, so 16, and then 64 is about there, and 1272. It's about right here. Okay. There we are. Okay. There's the sketch of our graph. I should label my axes. There's the X and Y. And there you have it. Okay, I'll make a few more videos for the other examples so that you can see all the solutions.